Let's look at a short exercise of defining a function. So what I'm doing here is defining a function that takes the minimum of two numbers x and y. And it says if x is smaller than y, the answer is x, otherwise the answer is y. If they're the same, of course, the answer will be y, which is x. So that gives us the minimum of those two. And the question I'd like to ask you is how you can define something that will give the minimum of three numbers, x, y, and z. So you can see the example there. If it's min t of 1, 2, and 4, it's 1. Min t of 2, 1, and 4 is 1, and so on. How can you define that function min t? Now what I suggest you do is you pause the video here, think about it, and then restart, and I'll discuss a solution. Right, looking at the solution. It would be possible, though very tedious, to take the definition of min as an example of a template, if you like, for how to do something similar but with three arguments. We'd need to think about the relationship between those three variables. If x is less than y, what about the value of z? How do we work with that? It's a bit complicated. Maybe you finish up scratching your head and thinking, why has he asked me such a tricky question? And the answer is that if you think about it in a slightly different way, the answer is really very straightforward indeed. And that's what you can see here. It says, don't think of the definition I gave you as a template, but think of it as a function that you can use. And here I'm saying the minimum of x, y, and z is where you take the minimum of x and whichever of x, y, and z is smaller, i.e. the minimum of y and z. So I apply the function minimum twice to x and then minimum applied to y and z. And that will give us the answer we want. So the brief lesson here is, remember, if you're reusing definitions that you've already seen, there's two ways you can do it. You can take them as a model, but you can also use that definition itself and use it as a component in the function that you're trying to define. So just giving you a slight perspective on how things might look different in a functional language.